So I've just been giving a prototype laser blaster to test. I mean, laser, welder, cutter and cleaner. Basically, ex-Laser Labs have given me their Photonics X1 Pro to test out. And what they're hoping is I advertise this for their Kickstarter program. But let's objectively look at this thing and see what's wrong with it. So because this is a prototype, they sent it to me to be scrutinized. And so based on my feedback, they'll make adjustments for the public product. I've got no instructions and no idea what I'm doing. I'm also highly aware that lasers are super dangerous, and I can't see a warning label anywhere. So hopefully I don't kill myself. We'll see, shall we? Right, so we're ready to turn it on. Let me just give you a synopsis of all the parts. We've obviously got the laser source with the laser torch. The torch actually came with a bunch of different nozzles to test out. And to feed metal in, we've got a wire spool holder, and I received a roll of stainless steel and aluminium. The aluminium is 1.1 millimeters thick, and the stainless steel is 0.9 millimeters. Also came with various cables, including this safety clamp. This is obviously thin gauge because it's just transmitting a signal, and so the welder will only weld to material that has been grounded with this clamp. You can obviously just bypass it by clamping it onto the nozzle though. But what it does mean is while we're welding material, if we lift off, it will automatically cut out, which I think is a very good safety feature to follow. And I guess the wire feed goes on something a bit like that. So I've been given lots of stainless steel bits to test out on. Let's fire it up and see how well it works. So for this I'm using pure argon gas, and I like to use pneumatic 6mm pushing connections, which fortunately for me is exactly what this welder requires. So I'm also going to feed this spool of stainless into the wire feeder. So now if I click wire feed, there we go, that should be enough. Now I believe the wire feed just tucks up underneath the nozzle here like that, until our little laser dot, as you can see, is just shining on the wire. So I've also got my ground clamp attached to the table and put my glasses on. Let's give it a quick test. I'm feeling very nervous about this. 1, 2, 3. I don't know what's going on. Right, so I finally figured out why it wasn't working. That button there, if I click that, you can see it's now glowing. There's a little indicator light at the top that says it's ready now to use. Also, if I click this button here, see that's now glowing. The wire feed should work also. Now it's armed, before it wasn't. I would highly recommend that that glows green and says armed or disarmed underneath it, just to be clear. Well, that's amazing. I'm going to try and do a wider weld. So that was with a spread of 4mm that time, and it's ever so slightly concave, so I need to increase the wire feed for that. Oh, I'm going to get some mild steel and we can do an etch test. Don't know if you can tell, but my fear is starting to turn into excitement. But something I will note right now for your safety, and that is when welding stainless steel, you've got to be careful of hexavalent chromium oxides. Extremely bad for your health, so make sure you wear a respirator. So I'm going to put my homemade one on right now. I think the key is to just pull it away quickly and then it stops the connection. I mean, that is just amazing. I mean, just look at it. And that was so fast as well. I can't do an etch test on the stainless. Let's do it on the mild steel. Right then, time for a proper test. This stuff is 10mm thick mild steel. I've got the settings on 100% power, 50 Hz, and a width of 2mm. Alright, so let's see how that turned out. That is so small! The width of that weld came out to, 2mm. I mean, that is amazingly perfect. Let's cut it open and see what it's like inside. I mean, I'm in shock a little bit, because you see these things on the internet coming from China, and you never know whether to trust them or not. Like, was the footage sped up at all? So I'm glad they've finally given one to an Englishman to test it for you. Right, I'll tell you what, my saw did not like going through that stainless weld. It's going all over the place. No, I'll have to cut it with a grinding disc, I think. And what happened was, I went through the stainless and just destroyed the teeth just on one side. So now it's just cutting skew-if. I'll have to replace the blade on it. Right, that was done to 240 grit. I can already see that's looking amazing. Hang on. Right, so what I'm going to do is add a solution of hydrochloric acid. Oh my goodness. Right, I'll neutralise that. Look at that. That weld depth is 2.5 millimeters. What that means is, despite that being a tiny weld, that has got tons of strength. As a root run, that is excellent. Let's just quickly do a destructive test. Alright, so I'm in the blacksmithing shed on my good old anvil. And the irony isn't lost on me here. Using our most ancient technology to test out the latest. Alright, so with the weld underneath, I'm going to hit against the weld. Let's see how much abuse it can handle. A lot less than I thought it would. Right, so that was actually quite a brittle weld and actually snapped directly in half. I'm wondering if I change the wire feed from stainless to mild steel and then increase the width of the weld to something like 5 millimeters or so. And so we'll see if this thing is actually capable of making anything structural. Right, I've put my 15 kilo spool of 0.8 millimeter mild steel wire. I've changed the settings to 100% power, 50 Hertz, and I've changed the weld width to 4 millimeters. I've also gone into settings, gone on wire feeding and range management, and I've changed the wire feed speed from 7 millimeters per second to 10 millimeters per second. Right, let's go for it. I can actually see I was angled quite wrong. I was focused more on the bottom plate than I was on this top one. I wonder if I can just weld another bead across it. That is a lot better. So then that weld is now just under 4 millimeters. It's really cool that you can see the heat affected zone just on the end there. It's so small. Right, how about we give that a crack on the anvil then? So then face down going against the weld. Come on. Ah, finally. Look at the actual depth of that penetration. That is incredible how deep that actually is. That is amazing. And look, that's actually cracked around the weld, taking a massive chunk of that steel off. What's it like with super thin material? Right, so now we're on day 2 and I think we should do something interesting. I've done a lot of playing with the settings and I think I've nailed it. At the very same time this video is being released, I've done a video on a pressure washer with the intent to do hydroforming. So I've got some 1mm 304 stainless steel. I drew up some templates. Let's cut it out. Now stainless steel isn't magnetic, but my table is. So I'll hold this down with a few magnets. And I like to use a jumbo fat marker to just draw around it. There we go, something like that. And so now I use my electronic shears to cut this out. You're probably wondering why I don't use the laser to cut it out. Quite simply, I can do it more precisely and more cleaner with this. I will test the cutting with this, but really I want to use this on a CNC machine. Right, let's give that a go. So I can see I wobbled a little bit just there. I think I'll actually go over that again and make it wider. That should do nicely. But I've got full penetration on the back, so I'm happy. So you might be thinking, this shape looks familiar. That's because Colin Furze did exactly the same thing for his grass trike. He actually copied the idea from Connor Holland, another channel that I highly recommend. And so once we've welded this up and I attach my new compressor, which delivers 3,950 psi, well, that's going to both test the welding as well as make it completely spherical. But I've also got another trick I want to test. You may have noticed that I'm able to get excellent consistency because I'm actually traveling at the feed rate of the wire. So essentially the wire is actually pushing me along, and that's how I'm able to get excellent results. So for cylindrical welds, I had an idea. That is to use a lazy Susan. So hopefully the wire feed should keep it spinning and get an excellent weld. So first of all, I'm going to get it centered up, watching the pottery channels, then kind of like tap it. That is actually harder than it looks. Awful, awful, awful. There we go. I've got some pinholes there. Oh, it was going so well. Well, I made a ton of mistakes, but I was able to kind of fix them, and then I finally got something that I wanted. I hate it. It's going to leak like a sieve. I'm going to restart that again. Right, so it's now day 3. I've learned from my mistakes. I've taken better care at cutting the material, and I've also done more weld tests to get the perfect setting. So I'm finally getting the results I'm after. And just so you can see, I'm now on just 30% power. 15 Hertz, this is the frequency in which the laser is operating. The beam is actually switching on and off at a frequency. And so the higher the frequency, the more intense that beam is going to be also. I've kept the width at 2 millimeters, and the wire feed speed is at 6 millimeters per second. So now I know this welder can do it, I'm going to accept nothing but perfection. Let's get tacked up. Done. So you can see my fit-up's a lot tighter. Just like TIG welding, you cannot have any excessive gaps. Unfortunately, these seams are still not perfect. And that was mainly because it's hard to see where I'm going to keep straight. I think in the future I'll clamp a block to the side of the weld, and that way I can just rest against it, let the wire feed push me along, and it should be dead straight. But anyway, let's weld this up. And something else you'll notice, I am not using the lazy Susan. That actually requires more skill than it looks. Not to say it's impossible to do, but I need to figure it out a bit better. So instead I've opted for the corner nozzle, I'm just going to let the wire feed do what it wants. Oh, come on. It's really hard to keep that wire in the middle where it's meant to be. Finally, I think I've figured this thing out. So very frustratingly, I didn't achieve perfection as I wanted. I did, however, learn why. As you can see, a portion of the welds did turn out really nice. However, my results were extremely inconsistent. My test pieces were coming out perfect, so what was going on? Well, first of all, see how the wire is nice and centered? The moment I tilt it, however, it goes off-centered. So the wire was constantly moving away from the actual weld pool, making it almost impossible to do. So I tried to get the nozzle as close to the weld pool as possible, and so I had to keep making adjustments here to try and correct what was going on here. The other thing, the torch nozzles, even though this is locked down, see how it twists? It's not quite holding it securely enough for some reason, and so as time goes by, it just takes a simple knock, that wire's come out of alignment and your weld's going all over the place. My biggest frustration, however, is that little black button there. They've got it so you can switch between settings, so you can imagine my frustration when I've got everything dialed in perfectly, just to accidentally press that button and then change all of my settings. Another frustration I have, if you don't have the perfect angle, then you're not actually getting the pushback. And so the welding stalls and you're just feeding material into the weld pool. So some areas are more bulbous than others. From what I've seen, they promote these laser welders to make it look like you'll be an instantly good welder if you use one. But that's obviously not true because you need to get the settings just right for the specific material you're working with. I used to consider myself as a good welder, but if you look at this, it looks like I've gotten worse. Anyway, let's pressure test these. As you can see, I've drilled a hole and we're just going to weld this nut on. This will then accept a pressure washer quick connect. However, this nut is obviously coated in zinc. So first of all, I'm going to use the laser to take off the zinc coating. So what I've done is I've taken off the nozzle and I've also pushed the torch head right back. I've set the laser width to 8mm, set the frequency to 100 Hz and at 50% power. Let me show you what it can do. And if you're doing the same, make sure you wear a respirator. And that is a really cool function. I'm going to be cleaning everything now. So that's before, that's after. Pretty cool. You just got to be careful you don't put too much power or have it too in focus, or otherwise you'll actually mark the surface of the metal. So then, we're ready. So we're using this 7 horsepower pressure washer from Fibre. So the idea is we pre-fill this with water. So without the pressure washer turned on, I'm just going to fill it up a bit more. I'm going to attach on our quick connector, dribble a bit more into there. Now we can connect it on. So I'm going to hide behind my workshop door. Let's turn on the compressor and give it a go. We do have a slight leak. Tiny bit more. Alright, I'll do. Look at that. Alright, how much pressure's still in it? Oh, not too bad. That has worked an absolute treat. All the welds held up apart from a few pinholes. Let's have another go with my first attempt. Now, the welding was particularly bad on this one, I think. Well, that's not a good start, is it? Let's see if it'll still form even with a hole like that on it. Whoa! In fact, I think it's failed because the weld wasn't quite on the seam. Oh well, you live and learn. So we're now on day 4 and I want to test the cutting ability and how well we can weld aluminium. And these, by the way, seem to make good sunglasses. And just for those who are interested, I'm developing more sculpture patterns. You can find the patterns to this one, for example, in my Etsy shop. There'll be a link in the description. You get a PDF and DXF files for laser cutting. I actually welded this lovely boy using a stick welder, but I'll do a remake of that tutorial with the laser coming soon. In the meantime, if you've seen my pressure washer video, I've got a big problem with moss on my roof. I failed to get it off with the pressure washer and I'm not allowed up there. So instead, I need to make a big scraping device. And randomly, I have these 6-meter lengths of aluminium pipe. I actually bought this to make an e-bike sidecar. That's another project that I promised to do, although it's changing a bit. So I'm going to cut and weld together a scraping device. At least that's the idea. Let's see how it goes. So I've just put a cutting tip on and I've switched my gas to compressed air. I asked X Laser Labs for advice and they said nitrogen is what you're meant to use. And I've ordered nitrogen bottles, they're coming. But the way this is going to cut, you need quite high pressure. So essentially as it melts the metal, it blows it out of the way. But from my experience using a plasma cutter, you kind of want it to oxidize away also. Laser Labs actually said they've never tried it with compressed air. I, however, tested it straight away. Let me show you. Now this, ladies and gentlemen, is 6mm mild steel. It's also 100mm wide or 4 inches. I've got it on 100% power, 50 Hz. Now, got to go a little bit slower than that, sorry. Just cut the end off quick. There we go. So if you're going nice and steady, that's the kind of result you can get. But check out how thin that cut is. That is actually way less than 0.5 millimeter. So I would say 6 millimeters is probably a maximum to cut. This pipe I tested on though is 3 millimeters. Let me just quickly pop another hole there for you. Easy done. When the fan kicks in, it is quite loud. Very good, it's got powerful fans though, keeping it cool. Alright, there we go. Yeah, look at that. It made a spoon. So that's obviously extremely rough because I freehanded it. Just imagine if I attach it to a desktop laser CNC and run light burn on it. The cost of thin gauge bespoke parts will be incredibly reduced for people. Now the thing is, using it like this comes with incredible risk, and so anything in the line of sight could get badly damaged. For example, so can you imagine someone cutting off a piece of a car and accidentally hitting the fuel tank? If these do come to the UK market, grab them whilst you can. 100% my government's going to ban this. What's also incredible is the actual range of this thing. But not only that, but the laser isn't in the visual spectrum. But as you can see, just because it's not in the visual spectrum doesn't mean it can't cause damage. Now these glasses are actually CE marked and have two ratings, 800 to 900 nanometers OD6 and 900 to 1100 nanometers OD7. I think the classification is DIN4. You can actually see the numbers just there if I zoom in for you. Anyway, let's cut some aluminium. I'm going to use this bit of wood as a template, so I go cutting it out. Here we are. So I need to practice and get a much better feel for the speed. As you can imagine with a CNC, that's just going to be perfect every time. Right, I think I've nailed aluminium settings. This is uncleaned, by the way. And that is 3 millimeters wide. Absolutely perfect profile. And that's at 75% power, 50 hertz, 2 mil wide beam, 10 millimeters per second feed rate, and shielded with argon gas. Let's try it on my scraper. Alright, so because this is so long, I'm having to weld with the door open. That obviously poses a good risk. So I must be very thoughtful how I actually angle this laser, that I don't hit anything else as well. I don't think that hit into this plate, so I'm going to go again, angle it a bit more. There we go. Terrible, but equally beautiful. I mean, it's not going to take a lot of practice to get that dialed in nice. And then the question is, will it scrape? I just realised I've just created a lot of work for myself. Should have delegated this for someone else to do. Still, I better get it done, otherwise YouTube commenters will be mean to me. I don't actually care because I've got a laser welder. So officially, this is now my most favourite tool. Now, Laser Labs have told me this will retail for $5,000. However, those that join the Kickstarter campaign will get 50% off. And if you didn't know already, this is Chinese technology. The US and the UK don't develop these for small businesses, so I don't know how it will work with the new American tariffs that are coming, and as I showed you earlier, the UK is definitely going to ban these. Because you can imagine it, can't you? Someone will point this in someone's eye, or ignite a fuel tank, and the government will turn around and say, well, that's why you can't have nice things. Meanwhile, the rest of the world will be getting these. And as you've seen, these can be 5 to 10 times faster than TIG welding. A typical TIG welder gets around about £35 an hour. So to get at least 5 times the amount of production out of them, that is a winner. If I was full-time TIG welding, I wouldn't think twice about purchasing one of these, because the return on investment will be substantial. Anyway, Laser Labs and myself are looking forward to your comments. These guys obviously want real feedback on their product for you, the customer, and I want to know what things you want to see me do with it. So if I can tempt you, why not try this video? And if not, how about you stop watching YouTube and get out there in the real world and forge for yourself a life worth living? I'll see you in the next episode. Bye-bye.